Hey, thanks for clicking on my video. If this video helps you, please consider liking this video and subscribing to my channel. It is greatly appreciated and it really helps. Let's get to the video. Hello everyone, let's talk about how we can evaluate some trigonometric functions. So it's a three-step process, and we also need to consider the signs of our values, which we'll see on the right. So let's jump in. So steps to finding a trigonometric function for any angle theta. Step number one, we want to find the reference angle for theta prime. Keep in mind, sometimes this might cause us to find a coterminal angle with our starting angle. So we might need to do that and then find the reference angle. Then we're going to evaluate the trigonometric function for theta prime. So this might involve using a special 30-60-90 or 45-45-90 right triangle, or also relying on our knowledge of the unit circle. And then step number three is determine the sign of the trig function value from the quadrant in which theta lies. So that's where we're going to use this table over here on the right. So for quadrant one, everything's positive. For quadrant two, sine and cosecant would be positive, but cosine, secant, tangent, and cotangent will be negative. Quadrant three, sine, cosecant, cosine, and secant will be negative, but cotangent and tangent will be positive. And then quadrant four, sine and cosecant are negative, tangent and cotangent are negative, but cosine and secant would be positive, okay? So we'll jump in. We're going to do 6 examples where we'll refer back to our sign values in each quadrant, and we also have a couple diagrams here at the bottom. Notice that down here on the bottom we have our 30, 60, 90 special right triangle, and then we have our 45, 45, 90. So we'll be using that to help us find these values as well, okay? All right, starting with number one, we have cotangent of negative 210 degrees. So let's think about where this angle would lie. So negative 210, we're going to be going clockwise, and we're going to get past 180. So this is going to be actually in quadrant number 2. So quadrant 2, and it's cotangent. So let's go back up here. Quadrant 2, cotangent says needs to be negative. So we go down here, and we're just going to make a little note. Hey, our final answer should be negative. Okay, so now for negative 210, let's think about what a coterminal angle would be in quadrant number 2. So negative 210 means we're 30 degrees past 180, which means the reference angle there is going to be 30 degrees. So 150 would be our coterminal angle. So this would be our coterminal. So now our rules for finding the reference angle would be in quadrant 2, 180 minus 150. And so now we have 30 degrees. So now we want to find essentially cotangent of 30 degrees. So let's look down here at our 30, 60, 90. So our 30 degree angle would be this small angle over here. So cotangent is the inverse of tangent. Well, tangent is opposite over adjacent, so this should be adjacent over opposite. So in this case, it's going to be root 3 divided by 1, or in just, well, simplifying, just root 3. But also we need to keep in mind that our value should be negative. So negative root 3 would be the answer for cotangent of negative 210 degrees. All right, cosine of 10 pi over 4. This one is a little bit different. Let's think about where 10 pi over 4 would be. Well, if we reduce this, this is going to be 5 pi over 2. And so now if we think about where this would be, 5 pi over 2. Well, 2 pi over 2 would be 1 pi, right? And then we have another 2 pi over 2, which is another 1 pi. And so now we're left with just pi over 2. So if we think about pi over 2, where would pi over 2 be located? Well, that would be pi over 2, that would be located at 90 degrees. So now we can use our knowledge of our unit circle, because 90 degrees, we know that in our unit circle, the point would be 0, 0, 1, and cosine is equal to the x value. So in this case, cosine is just going to be equal to 0, right? Because that would be 0, 1, cosine is equal to the x value. So cosine of 10 pi over 4, 0. Number 3, tangent of negative 3 pi over 4. So let's think about where negative 3 pi over 4 would land us. So our terminal side, we're going to be, it's negative, so we're going clockwise. So negative 3 pi over 4, we're going to end up in quadrant number 3. So quadrant 3. And we need to look at tangent in quadrant 3. So tangent in quadrant 3, so we need to be positive. Okay? All right, so now quadrant 3, negative 3 pi over 4. So if we think about our distance from negative 3 pi over 4 back to the x-axis in that would be between quadrants 3 and quadrants 2, and that's going to give us a distance of pi over 4. because essentially what we're going to be doing is 3 pi over 4. We would subtract that from pi. And so pi minus 3 over 4 is going to give us pi over 4 as our reference angle. Now, pi over 4, if we convert that to degrees, this would be equal to 45 degrees. And so now we can use our special 45, 45, 90 down here at the bottom. So for tangent, it's just opposite over adjacent. So opposite over adjacent, either one of these angles would be 45 degrees. So we can see our answer is just going to be 1. All right, now for number 4, cosecant 17 pi over 6. So let's try and reduce this fraction a little bit. 17 pi over 6, well, we know 12 of those, 12 pi over 6 would be 2. So we're left with 5 pi over 6. So 5 pi over 6, if we think about our angles, this is going to end up in quadrant number 2 because 6 pi over 6 would be pi, and that's right at 180 degrees. So cosecant in quadrant 2, cosecant quadrant 2 should be positive. So we know this one's going to be positive. All right, so now 5 pi over 6, so our reference angle, we're going to do pi minus 5 pi over 6, and we're going to end up with just pi over 6, okay, as our reference angle. So if we think about pi over 6 in terms of degrees, this would be like 180 pi over 6, or in other words, 30 degrees. So this would be the same as 30 degrees. So now we can look at our special 30, 60, 90 right triangle. And we're going to look at cosecant, which would be the inverse of sine. So sine of 30 would be 1 over 2. So in this case, our answer would just be 2. All right. And number 5, sine of negative 150. So negative 150 degrees, that's going to take us clockwise, not quite to 180. So we're still going to be in quadrant number 3. And sine in quadrant 3 is negative. So we know our answer needs to be negative here. All right, so if we're at negative 150, then we know that that would be 30 degrees before 180, or in terms of a positive, that'd be 30 degrees past. So our coterminal angle would be 210 degrees. We can subtract that minus 180, and we're going to get 30 degrees. So now let's think about sine of 30. So we can look at our 30, 60, 90 triangle at the bottom left here. Sine of 30 would be opposite over hypotenuse. So in this case, it would be 1/2. And we need to make sure it's negative. So negative 1/2 would be our evaluation. And lastly, number 6, secant of 135. So 135 is going to be in quadrant number 2, which means we can do 180 minus 135 to find our reference angle, which would be 45 degrees. And secant is going to be our reciprocal of cosine. So if we look at our 45, 45, 90, cosine adjacent over hypotenuse would be 1 over root 2. So we know this one is going to be root 2. And then we forgot to look at our function value or our sine. So let's go secant in quadrant 2, and that should be negative. So now we go down here, and this should be negative root 2. Okay, and that's how you can evaluate some trigonometric functions.